welcome back to another lesson. Today's learning goals are I can compare integers using less than, greater than, or and equal to by identifying their positions on a number line. I understand that the absolute value of a number is its distance from zero, and I can identify rational and irrational numbers based on their characteristics. A lot of things we will be learning today, so let's go ahead and get started. A rational number is any number that can be written as a fraction. These numbers, when written as a decimal, will either stop, terminate, or repeat endlessly, non-terminating. So they will either repeat endlessly or stop. Okay, so notice the repeat endlessly part. Okay, it has to be repeating, not just going on and on and on forever. Irrational numbers are any numbers that are not rational. For example, the square root of non-perfect squares. So like the square root of 5, square root of 10. However, something like the square root of 25, now that is rational because the square root of 25 is just 5. And 5 can be written as a fraction. 5 over 1 is the same thing as 5. Here, 12 is going to be considered rational. So we're circling all the numbers that are rational. 12 is going to be considered rational. That can be written as a fraction. 12 over 1. 12, 23 with 23 repeating. 12.23 with 23 repeating, excuse me. That's rational because we said that it repeats endlessly. Okay? Repeats endlessly. So right here, that is going to be rational and this is going to be rational. Specifically, the fraction for this one is 12 23rds 99. You don't necessarily need to know that. That is the truth. Here, square root of 49. We know that to be 7, and 7 can be written as a fraction 7 over 1. So that is rational. Unfortunately, 2 pi is not, because pi, remember, is let me use a different color. 3.14159, etc., etc., etc. It goes on and on, but does not repeat. Does not repeat. So therefore, this is irrational. Square root of 2. 2 is not a perfect square, so this is going to also be rational, meaning that it is a number that's like 1.413, something like that. It goes on and on and on forever, but does not repeat. So that is irrational. 4/5. That is going to be a terminating decimal, because that's 0.8, but it's also can be written as a fraction. Any number that can be written as a fraction. So since this is a fraction, that is going to be a rational number. 2 and 2/100ths is going to be rational because that can be written as 2 and 2/100ths. Okay, and it's also a terminating decimal. Go ahead and try to identify the rational numbers in the next example. What you should have found is square root of 16 is rational because that's the same thing as 4. 4 is 4 over 1. Over here, 3.11, this is a repeating decimal, so therefore it is rational. This is already written as a fraction, so that's rational. This is a terminating decimal, it's rational. 66 can be written as 66 over 1, so therefore that is rational as well. The irrational ones are pi, as we talked about earlier. Pi keeps going on and on forever, but does not repeat. And the square root of imperfect squares are also irrational, so therefore they are not rational. Moving on, we're going to talk about integers. Okay, integers and other rational numbers. As we know, integers are rational numbers because we just said that something like 3 can be written as 3 over 1, so therefore it is a rational number. Integers are positive and negative whole numbers. They're shown on a number line. Positive numbers increase as they move farther away from 0. Negative numbers decrease as they move farther away from 0. Examples of integers. You can think about things like the weather. Okay, we have like -3 degrees Fahrenheit. So we're using positive and negative numbers to talk about the temperature in weather. In sports, such as golf. Okay, so we have scores like 4 under par. Or in football, we have things like -3 yards on the play. At the bank, you also use negative numbers when you withdraw money. So let's say I withdraw $100. You write that as negative $100. Or if you have a balance that's negative, like you borrowed money from the bank, you also have negative amounts of money. So let's say you owe the bank $3,000. That's negative $3,000. So we need to figure out here, comparing integers, using the less than, greater than, or equal to signs. So remember that the alligator mouth goes to the one that's bigger. So -5 and -3. -3 is bigger than -5 because you would rather owe $3 than $5. Over here, we have -100 and -3. -3 is bigger than -100, again, because you would rather owe $3 than owe $100. Here, 0 is greater than -12, again, for the same reason. You would rather owe no money than $12. And here, 8 is greater than -6. The reason is because you'd rather have $8 than owe $6. Remember, the negative indicates owing or being down that amount. Go ahead and try to order these numbers from least to greatest. What you should have found is that the smallest number is -14, -8, -5, -4, -2, 0, 1, 3, 5, 8, and 12. Again, it's going from the least amount, which is the biggest negative number, so the most negative number, I guess that's the best way of putting it, the most negative number, and then going up to the highest positive number. Absolute value. Absolute value is the distance a number is from 0. Absolute value is always positive and can never be negative. The symbol for absolute value is 2 lines straight up and down. So for example, the absolute value of 4 would look like this. Okay? So the absolute value, therefore, of 4 is just 4. The absolute value of -7 is just 7. So absolute value is just the positive form of any number. If it's already positive, it just stays positive. Okay? Always positive. It's the distance a number is away from 0 on a number line. So examples of this in real life include talking about direction. So for example, if we say that we went 3 feet or 3 miles east, then go 4 miles west, we don't say that we go -3 miles west. We say we go 3 miles east. So when we're talking about directions, we talk about the absolute value going left or right, east or west. We don't say negative numbers. We use the positive version of them. So therefore, it is going to be, it's going to be like 3 miles east. Also, when we talk about, for example, withdrawing money from a bank, we don't say we withdrew -$300, even though that's exactly what we're doing. We say we withdrew the positive version of that. We withdrew $300. Okay? So, when we are using everyday conversations, we take the absolute value of a lot of different things. The absolute value of -4, well, we just take the positive version of that, 4. The absolute value of 4 is going to be 4. We're going to take the absolute value of -3 plus it with the absolute value of 2, so this is going to be 3, because the absolute value of -3 is 3, plus 2, which is 5. Here, the negative sign is on the outside of this absolute sign. So what we first do is take the absolute sign, absolute value of 4, which is 4, and then put the negative sign. Because this negative sign is not inside the absolute value, we don't make it positive. We keep it negative. This is going to be -4. Okay. So you can sort of think about integers and numbers, that are negative numbers, as numbers that are on a mirror. Okay. On one side is 1/2. On the other side of the mirror, equally distant as far away, is -1/2. So the absolute value of -1/2 is going to be 1/2. It's 1/2 away from 0. -3/5, the absolute value of that is going to be 3/5. Okay. Both of these are the same distance away from 0. Find the absolute values of -1/3 and 4/5. Go ahead and try this one out on your own. What you should have found is that the absolute value of negative 1/3 is positive 1/3, and the absolute value of 4/5 is still 4/5. Using the number line below, show how far negative 1/3 and 4/5 are away from 0. Which one is closer to 0? Well, negative 1/3 should be right here. This is negative 1/3, and it is 1/3 away. Let's use a different color. 1/3 of a spot away from 0. Here, 4/5, we're going to split this into 5 equal parts. 1, 2, 3, 4, and then 5 is going to be the 1 right here, because 5 over 5 is 1. And then we will use 4/5, so 4/5 is right here. We can see visually that 4/5 is farther away from 0 than negative 1/3. So 4/5 is farther away from 0.